Hello, my name is Martin Smith, and I'm here to talk about the Great Slow. I'm trying to rename it Velocity Syphon. And what I'm doing is I came up with this really stupid idea. It was too simple. And the idea that within 100 years that the greatest minds in the world just missed it, I consider to be quite hilarious. So I gave it a real stupid name, and I was pretty much laughing about it the whole time I thought about it. And that is to say that gravity, traveling at the speed of light, has consequences. And in 1984, I asked someone in the physics department at Appalachian State what the velocity of gravity was, and I was told that the basic idea of it, or the common idea, is that it was traveling at the same speed of light. And so that tells me that the concept of gravity having the same velocity as light was known for quite some time. And like I said, the idea that nobody ever thought through the real simple consequences of it seemed really stupid to me, and I considered it to be a joke. And after time, I've been looking for it, and I may just not know the name of the idea, so it could already be out there, and I'm just ignorant of the facts. So anyhow, the idea of naming it The Great Slow seems to be rather a poor one, so I'm going to rename it. If I am the one that figured this out, then I'm going to rename it Velocity Syphon. That means that two objects traveling this way, say they're in either a rotational form in some direction, but as they're traveling close to the speed of light, that means that, or I should do it this way, that the gravity for this one is not here, because it takes time for it to get from here to here, the effects of gravity. Plus, it's traveling, so the time it takes for light or for gravity effects to get from this point to this point would affect where the gravity would be coming from. Now we take the velocity versus the speed of light, and we make a triangle, and so that the effects of gravity on this one to that one would be behind it. And what's happening as this system is traveling forward is that it would actually be slowing down the system, because you have gravity affecting it. The gravity that's keeping them in a circle is pulling them together, but it's also pulling them backwards as it's traveling in this direction. And that's the basic concept of the Great Slow. So, renaming it Velocity Syphon, because that's pretty much what it's doing, is it's siphoning out velocity of a system, a closed system, or a group of objects traveling through space. So it is only the velocity in this direction that is being siphoned out. If you have multiple parts of an object going around this direction, then this speed here is also a velocity. However, this velocity is extremely slow, and like I said, it is a ratio of speed of light to velocity. So if the velocity of two objects going around each other is real slow, or if multiple objects going around each other is real slow, then the velocity siphon would have very little effect on the spin of those systems. I mean, it wouldn't really draw it out much, because it's a ratio. However, if it is traveling through space close to the speed of light, or any significant speed, say 1/300th the speed of light, then the triangle, or the effects, the shift of gravity behind the object on the other object, and vice versa, would have some very large effects on slowing things down. Or I see this system seen within galaxies, and I'm also wanting to explain an oddball phenomena with a galaxy to which the outside of the arms are spinning one direction and the inside of the arms are spinning in the opposite direction. The idea of a galaxy, and to give the idea of a small galaxy that's formed outside the system. So if this galaxy is spinning in this direction, and they are moving through space in this direction, and notice I'm not saying they're moving this way. They have to be moving exactly in exactly the direction of the plane. So if this one's moving this direction, and this one here is nice and fluffy, and it slows down, as in this big one gets slowed down less than the little fluffy galaxy, because its particles would have different attributes and wouldn't necessarily be slowed down as much. Then what's going to happen is when they collide, I'm going to flip it, the collision of galaxies generally bypass the stars. However, they do not bypass the center point of the black holes. So we have two black holes. One black hole is spinning in this direction, and another black hole is coming to it, but it's not coming to it from this direction, it's coming to it from this direction. And velocity times lever arm, or force times lever arm, whichever you prefer to think of it. So even though this black hole is really small, its velocity added to this one could actually change the direction of the black hole inside the galaxy. So when we have the outside arms going in this direction, the actual black holes would merge, and the larger black hole, or the galaxy that is consuming this, the big galaxy that's consuming the small one, would change directions. Okay, if you want to read this, you can pause on it, and I'm going to move on a little bit, starting with a blank page, and I'm going to start with a galaxy and how I see they form, or in my opinion of how they form. So I'm going to start with a black hole, and I'm going outwards. There are theories or possibly ideas, I'm not sure which, that a galaxy starts from a cluster of dust, and as it is pulled forward, the gravitational waves have a circling form, and it's the gravitational waves of the dust collects, and the dust makes the arms, and then it's sucked inwards towards the black hole itself. In this one, the velocity siphon would take the dust and slow it down, and the dust would actually be coming into the center, giving it greater spin, and that spin has to dissipate in some form. So I'm assuming that the spin is collected, and in some process that is still unknown to me anyway, the black hole actually pivots in a direction. So instead of becoming a quasar, we see two with the quasar blast areas of the poles of it get turned 90 degrees, and these are the poles in which we see in the center of the galaxy. And from here, both the dust and the energy gets thrown out, and we have suns being created here. And as it spins, we would have galaxies being thrown out in this direction. Now, the second aspect of the velocity siphon would say that some of these particles over time would clump together, and their masses would become similar, as in we have two masses, say here and here. And what's going to happen is as they develop and they start spinning around each other, they actually get closer and start spinning around each other. The gravitational siphon is actually going to slow them down within this system too, and once this system becomes prevalent, it's going to slow itself down in the galaxy, and second arms in the galaxy would be created. So we have a velocity siphon creating this second or even multiple, because the effects would be different over time. So as the galaxy ages, this stuff just gets more and more dispersed, and then the clouds start developing over here more. So what's happening is, over time, as galaxies get bigger, they create little subgalaxies. And we're going to go that way. And I guess I should put arms on this thing. The center arms, like that. So much for artwork. And dust and other things get kicked out, including black holes. So we have a small black hole here and a large one here. And they're not only on the same plane, but it just so happens in one particular case that the plane itself, as in this whole piece of paper and the whole plane, is traveling in a direction that's not this way, not that way, but exactly in the direction of the plane. Or one of these two is being slowed down at a different velocity or a different siphon force than the other one. So we have a high velocity this way, and they are also being drawn towards each other. So if this one's spinning in this direction, and it is slowed down less than the small one, as the small one is drawn back to it in gravity, it's actually going to be, so this system here comes in here and starts spinning this way, whereas this galaxy spinning this direction, the dust around here would have no effect on the larger objects, or at least very, very little effect. And this spin would eventually, the energy of that spin, the spin energy of that spin would be greater than the spin energy within the black hole, and it would change the direction of the spin of the black hole. So what we would be seeing now is a black hole. If I can just change one of them, and we'd have arms inside the second arms. Actually, the spin would be that way. So the velocity of these parts would be in this direction. The velocity of the arms themselves would be going, make vectors on it. I guess the small ones would be going faster, and the ones on the outside would be going approximately the same. So we have multiple gravity chains and multiple slowing effects. And what I'm looking at here is a system where the outside of the galaxy is moving in one direction and the inside of the galaxy is moving in the other direction. And this system has been seen at least once, and I'm linking a video to it. If you could go down into the links, I left a link. So half this video is based on another video, and you really have to go down to the links to find it. And it has to do with density wave theory, which is an opposite theory to what I am working with. And I am trying to explain this particular galaxy using the velocity siphon method. And I'll be going over all that later. So other aspects of the velocity siphon would be whether or not we have the main mass in the center versus and a very small mass going around it versus two masses going around each other. So the two large masses, let's say they're both moving in this direction. Two large masses here and here would have a greater, so the center, the actual mass that's affecting this one is back here, and it would have a greater force applied to this one in that direction. Forces applied. So this one here, the forces would be greater, and it would slow it down more than this particular system here, where all the mass is in the center. So this one here would have the same velocity slowdown as the large mass, but the large mass, even though the mass of this one here, or the velocity of this one, is going at the same speed, this smaller mass here would have a very low slowdown. So it would have the effects, so the velocity of it is in this direction at a very high speed, high enough speed to have an effect, or there would be a triangle here, so that the forces of gravity that are keeping these things in orbit are also slowing it down to its velocity within space, or the framework of space. So what's happening here is we have two systems with a different rate of slowing down, and that's where I am getting this from, and I'm just putting it together. This is a thought experiment, and I'm not claiming it anything more than an idea. I'm not pushing it to a theory. It may very well be wrong, and I'll probably go on that in another video.